Okay, so this is looking back at exponential equations and what to do when bases can't be converted to match up. So if our bases can't be converted, we're going to take the log of both sides and then solve for a missing variable. Your answer will need to be rounded to the nearest 10,000ths, and that'll happen in your homework. Just make sure that you round it to 4 decimal places. So you're going to go pretty far back. Our first one we'll look at shows us that we can't, go from having a base of 5 and 20 and matching those up. So what we're going to do is take the log of both sides. So when I take the log of both sides, log of 5 to the x is equal to log base 10, right? Because it's not written 20. Then one of my log rules is that the exponent can now be moved to the front. Now becomes kind of like our little coefficient there. So it's now x log of 5 is equal to log of 20. I should write these parentheses, shouldn't I? There we go. And then now it's x times log of 5. So to get rid of the log of 5, so to get x by itself, I'm going to divide both sides by log of 5. And then your final answer, what you're going to do is type in log of 20 and log of 5, and you'll round it to the nearest 10,000. So that's 4 decimal places, and you'll go log of 20 divided by log of 5, and it's 1.861, and then I look and I have the 3, but there's a 5 after it, so I'm going to round up and go to 4 here. So watch your rounding for those. Next one, same idea. We just want to get n by itself, and 4 and 5 here can't be written, so what we're going to do is scoot this guy over. We're going to take the log of both sides. So now it becomes log of 4, 3n power is equal to log of 5. Take the log of both sides. That's going to be the part that kind of gets people. Then we got to remember that exponent can be moved to the front. So it's actually 3n log of 4 is equal to log 5. And then the whole thing, 3n, is being multiplied. So to undo that multiplication, I divide by log 4, log 4. And here's the fun part. It's actually also being multiplied, like 3 times n times the log of 4. And what I really want to get by itself is the n. So to get n by itself, I divide by log of 4 and the 3. So everything gets canceled, the 3 and the log 4. So I've got n all by itself, and I'll get log 5 and 3 log 4. And when you type it in, you just want to go log of 5, log of 4, and then divide by 3. So it's going to be 0.3870. For the next one, for this question, we want to get the x by itself, so we add 5 to both sides. I'll go with blue on this one. And then we want to take the log of both sides. So here we're going to take the log of both sides. So log, and what we do is bring that x to the front. So now it's x, whatever that exponent is, moves to the front of your log. X log 4 is equal to log 17. And then you have x times log of 4, so you divide by log of 4 on both sides. So cancel, cancel, and we're left with x is equal to log of 17 for the log of 4, and that'll be 2.0437. So we just got to make sure that when we do this, we're careful about what we're plugging into the calculator. Then our last one in this section, we have to get this guy by itself. And so we will subtract 10 from both sides. That's our first step. So we get negative 32 on that side. And this negative, we need to divide by negative 1 because it's not negative 7 to the x power. It's 7 to the x power and a negative. So we want to divide by negative 1. So that we're just left with 7 to the x power is equal to 32. And then now we're going to take the log of both sides and move that x to the front. And we'll divide both sides by log of 7. And that'll be our final answer. So after we get the term with the x by itself, we can just follow the same procedure as before. So it's the log of 32 divided by the log of 7. And we'll get 1.7810.